we have a problem. There's an electric motor that takes in electricity and outputs mechanical energy in the form of rotational movement. The question explains that there was an old motor, a 75 horsepower motor. That's the requirement for whatever the motor is supplying that shaft work to. It's a 75 horsepower shaft output motor. The old motor had an efficiency of 91%, and now it's being replaced by same size 75 horsepower motor, but the newer one with a higher efficiency at 95.4%. We have to determine the benefit in this replacement by looking at the reduction in the heat gain to the room where the motor is installed. So let's convert the output power, 75 horsepower, to kilowatts, which is a standard unit. So the conversion is 0.7457 kilowatts per 1 horsepower, and that results in 55.93 kilowatts. So we have a 55.9 kilowatt motor originally at 91%. So efficiency old is 91% and efficiency new is 95.4% or 0.954. Looking at the energy balance, if I take the system to be this, crossing the electrical wires where the electric power comes in, and also crossing the shaft where the mechanical power goes out. Because this is not a 100% conversion, so there will be some loss to the environment, which is the room, and we call that W dot loss, and we're trying to determine that. So we have W dot electric in as output, we have W dot mechanical, W dot shaft out. That's our energy balance. Basically, W dot electric in will result in two components. W dot, I use shaft here instead of mechanical, W dot shaft out plus W dot loss. So let's use the definition of overall efficiency here, which is the desired output, W dot shaft out, over the required input, which is W dot electric in. So now we can calculate the required electrical work for both cases, old and new. So let's do for old first. So W dot electric in old is equal to W dot shaft out divided by old efficiency, or 55.93 divided by 0.91 is equal to 61.46 kilowatts. This means that the old motor required 61.46 kilowatts of electric power in to produce 55.93 kilowatt of power. So W dot loss for the old motor is the difference between 61.46 and 55.93, which was 5.53 kilowatt. That's the old loss, which is equal to the energy added to the room. Next is the new case, the new motor. Same equations apply. So W dot electric in new is the output required is the same, 55.93. Now the efficiency is a little bit better, 95.4%, and the required electric power is 58.63 kilowatt. Therefore, W dot loss for the new motor is again the difference between the required electric power and the desired output mechanical, which is 2.7 kilowatts. So by comparing these two values, new heat added to the room and the old heat added to the room, you can see that there is a significant difference between the two, meaning replacing the motor will definitely be beneficial in terms of electricity used for providing 75 horsepower of output shaft work, as well as it's beneficial in reducing the amount of heat added to the room.